Suppose it's 10 o'clock in the evening and you set your alarm for tomorrow morning to arrive early at your school. As you set the time, the notification shows that the alarm will remind in 7 hours. What is the time that you have set? If you have set the alarm at exactly 10 o'clock in the evening and the notification shows that it will remind you in 7 hours, basically the time that you have set in the alarm is 7 hours after 10 p.m. So by counting the 7 hours after p.m., the alarm will remind at exactly 5 a.m. Okay, we got the answer by just simply counting that 7 hours after 10 p.m. But how can we answer those number of hours that is more than that 7 hours, and we cannot obtain it by just mere counting? So what will we do? Okay, so this topic actually will focus on one of the mathematical concepts which will help us in our problem. And this topic is called as the modular arithmetic. Okay, this is called as the modular arithmetic. So here in Unit 4, we have different applications that we might encounter here. So for Unit 4, our topic is about the mathematical systems. Okay, so the practical applications of mathematical systems in one's daily living is what everyone is trying to seek. For instance, the concept of the time, the concept of the day, and the date are manifestations of mathematics, which are very helpful in tracking events in the future or in the past. We also use as representation for the products we usually consume, but we are aware whether these products are legit or not. Okay, so with that, we're going to use the concept of the modular arithmetic. Okay, so for identifying the specific time, identifying the day of the week, and identifying the day of the week provided that we have the specific date. And lastly, we're going to verify the legitimacy of the given product. Okay, as we consider its barcode numbers. So going back to one of the applications which is about the time, let's have this first problem. Okay, so what is 14 hours after 4 a.m.? Okay, so as we all know, in our time we have two formats to consider. One is the military time, wherein we consider that 24 hours. While the other one is the 12-hour design clock, wherein we use the AM and PM. Okay, so AM refers to the antemeridian, or which means before midday, and then PM refers to the postmeridian, which is the same as the after midday. Okay, so here in our problem, we're going to use the concept of AM and PM. Okay, so we'll have the 12-hour design clock. Okay, to answer our problem here. So first up, let's have this one. Okay, by applying the concept of the modular arithmetic. Okay, so when it comes to the modular arithmetic, we're going to use the division. Okay, so in division, we're going to have our divisor, which is the 12. And our basis here is the 12-hour design. Okay, so now here in our problem, let's try to divide that 14 hours to 12. Okay, so 14 divided by 12, that is 1 remainder 2. Okay, this denotes that the hand of the clock passed through 12 only once. Therefore, as the hand of the clock returns to 4 after 12 hours, from AM it would become PM. Okay, so there's one cycle of 12 hours. So from 4 a.m., that is 4 p.m. And also, we have here our remainder, our excess. So just add that 2 more hours. So 4 p.m. plus 2 hours, the answer here is 6 p.m. Okay, so here, remember, we're going to use 12 as our divisor, and also you need to recall the concept of division in identifying the quotient and the remainder. Okay, let's have another problem. What is 100 hours after 4 a.m.? It is obvious that we cannot count that 100 hours before after 4 a.m. Okay, so for us to solve this, again, we're going to use the concept of the modular arithmetic, wherein we divide that 100 hours to 12. Okay, so 100 divided by 12, let's identify the quotient and the remainder. So we'll have here our quotient as 8 and the remainder here as 4. Okay, so now, what does it mean? What is quotient and what is the remainder? Okay, so the quotient, it refers to the reference time. If we're going to stay at our reference time 4 a.m. or we're going to shift it to p.m. Okay? And then for the remainder, it is the number of hours to be added if we are after with the after, or subtracted if we are looking for before. Okay, so now let's go back to the quotient here. So given that we have here as the reference time, let's see. Okay, the quotient. Let's say if you have one as your quotient, your reference time 4 a.m. we're going to shift to p.m. Okay, so there's 12 hours, one cycle of 12 hours here. So from 4 a.m. that will be 4 p.m. And then, if your quotient is 2, obviously, that is 12 hours. So, you'll have, again, AM. Okay, you'll shift again to AM. And then another 12 hours, and that is PM. And then another 12 hours, you're going to shift to AM. And then another 12 hours, you're going to shift to PM. And then another 12 hours, that's AM. Okay, so as you notice, it has something to do with these two cases, which is the odd quotient and the even quotient. If we have odd quotient here, remember that you're going to shift from AM to PM. Okay, and vice versa. If your reference time is PM, you're going to shift to AM. So remember, if you have an odd quotient, you need to shift. While if you have an even such as this 1, 2, 4, and 6, the reference time is the same. Okay, it will remain as AM. Okay, so now, looking at this, we have 8 as our quotient. Since 8 is our quotient here, the reference time for our answer would be the same. Okay, so given that we have 4 a.m., so obviously it's still 4 a.m. Okay, and then let's just add the excess of 4 hours. Okay, let's just add the excess of 4 hours. So 4 a.m. plus 4, that is 8 a.m. Okay, that is 8 a.m. So remember, if you have a quotient of even, your reference time is the same. Okay, it will remain the same. But if you have an odd reference time, that's the time that you will change it. Okay, so from AM to PM, then from PM to AM. Okay, so remember that. Okay, so let's have another example. What is 100 hours after 4 p.m.? Okay, what is 100 hours after 4 p.m.? So as you can see here, again, all we need to do is to divide that 100 hours to 12, and we'll have the same remainder and quotient. So we have 8 as our quotient, and then 4 as our remainder. So notice that our quotient here is 8 and 8 is even. So therefore, our reference time will be the same. Given that we have 4 p.m. here, so our reference time is 4 p.m. plus add that excess of 4 hours. So that is 8 p.m. So 4 p.m. plus 4 hours, that is 8 p.m. Another example. What is 100 hours before 1 p.m.? Okay, what is 100 hours before 1 p.m.? So again, let's divide that 100 to 12 and we'll have 8 as our quotient and 4 as our remainder. Okay, so given that 8 is even, therefore the reference time for our answer would be the same. But look at this. Look at this. So given that we have here the word before, instead of adding that 4 hours, we're going to subtract this. Okay, we're going to subtract this. Okay, so given that we have the same reference time, which is 1 p.m., let's just go back 4 hours. So from 1 p.m., go back 12 p.m., 11 a.m., 10 a.m., then 9 a.m. So therefore, we have here our answer as 9 a.m. So remember, if you have the word before, you need to subtract the remainder. Okay, you need to subtract the remainder. Another example, what is 112 hours before 4 p.m.? What is 112 hours before 4 p.m.? So here again, we're going to use the modular arithmetic. Let's divide 112 to 12. And the answer here is 9 remainder 4. Okay, 9 remainder 4. Okay, so given that we have 9 as our quotient, and obviously 9 is an odd number, so therefore, we're going to change our reference time. Given that we have here 4 p.m., we're going to shift it into 4 a.m. Okay, so that's 4 a.m. And then since we are dealing with the word before, okay, since we are dealing with the word before, let's just subtract that 4 hours. So given that we have 4 a.m., let's just subtract that 4 hours. So 4 a.m., that's 3 a.m., 2 a.m., 1 a.m., and that is 12 a.m. Okay, we need to subtract it because of the word before. So what is 112 hours before 4 p.m.? The answer here is 12 a.m. Okay, the answer here is 12 a.m. Another example. What is 247 hours after 3 p.m.? Okay, what is 247 hours after 3 p.m.? So same procedure. Let's just divide it by 12. 247 divided by 12. And the answer here is 20 remainder 7. Okay, so we have 20 remainder 7. So given that 20 as our quotient and 20 is even, so therefore, our reference time is the same. Okay, so the reference time is the same, which is 3 p.m. Okay, which is 3 p.m. And then we have the word after here. So since we have the word after here, all we need to do is to add that excess of 7 hours. Okay, so 3 p.m. plus 7 hours, that is 10 p.m. Okay, the answer here is 10 p.m. How about if we're after with the word before? Instead of the word after here, let's say we replace it with the word before. What is 247 hours before 3 p.m.? Actually, the quotient and the remainder is the same. Okay, so therefore, since 20 is still even, your reference time here is 3 p.m. But, since you have the word before, you need to subtract that 7 hours. Okay, we need to go back 7 hours. Okay, so from 3 p.m., you go back 7 hours. That's 2 p.m., 1 p.m., 12 p.m., 11 a.m., 10 a.m., 9 a.m., then 8 a.m. So what is 247 hours before 3 p.m.? The answer here is 8 a.m. So again, the quotient after dividing by 12, the given number of hours will tell us whether the reference time for the answer will shift or not. Okay, and the remainder will be the number of hours to be added and be subtracted from the reference time. So if the word is after, we're going to add, and if the word is before, then we're going to subtract.